starting down here, we have our single hill nursery, which means that every single one of these plants is an individual variety, a new variety. And then we move down this way. We leave part of it fallow each year, and we rotate the crops through. But the next section here is our multi-hill nursery, and so you'll see they're clustered in 4, 5, 6 varieties on either side of the hill. And then when we get down further this way, we're into our 20 hill and 40 hill plots, and each one of these is a 2-year stop. Breeding program, a traditional breeding program, it typically takes about 10 years to get from a cross to a potential new commercial variety, like we'll see in the 5-acre plots. So what our breeding program is not a traditional breeding program. It's actually very unique in the world. It's a molecular marker assisted selection. So we have mapped the genome of hops, and over the course of the last couple decades, we've genetically marked several traits in hops that allow us to make more informed crosses. For instance, we'll take disease resistance. That was really the first component that we wanted to mark, because powdery mildew and downy mildew are the 2 main disease pressures. We have powdery mildew here in Yakima, and what our genetic program allows us to do, our molecular marker assisted program allows us to do, is we can now look at the genetic traits of male plants as well as the female plants. In a traditional breeding program, only the female plants have cones, right? So you're only looking at the female traits of cone size, yield, etc. But the male obviously contributes a substantial amount to new varieties, right? So now we can look at males and actually see what kind of traits they're going to pass along to their daughters. For instance, as disease resistance, we can see a male plant has one disease resistance gene and a female plant has a different resistance gene. So when we cross them, some of the babies are going to have moms, some of the babies are going to have dads, some of the babies are going to have both. And what that allows us to do is we stack disease resistance into these varieties so that the disease can't break through that disease resistance. If they only have one gene, eventually the disease will break through that and it will no longer be disease resistant. But when you have that stacked resistance, the disease isn't able to break through that resistance. So that's just one example. And we've taken we've got several markers now that affect things like yield and disease resistance and drought resistance. And now the next frontier for us is aroma, where we're working on identifying specific molecular markers for aroma attributes. So what that also allows us to do is now we can skip some of these steps. So as I said, this field here is essentially 10 years worth of a breeding program, but what we've been able to do over the course of the last several years is we can skip some of these spots. We can find something maybe in the single hill nursery that looks really robust and has great aroma characteristics or alpha characteristics, depending on what we're going for. And then we can look at its genetics and understand that it's got specific agronomic components that we want, and we can skip a step, or in some cases we can skip 2 steps and take something from early in the program and advance it to late in the program. So we've shortened the breeding cycle because of our work with molecular marker assisted crosses and selection. So similar to what Nikolai was discussing in the seedling nursery, he's looking for robust plants that have good cone to leaf ratio. They have inside cones. They have good cone attributes, good yield attributes, and so now we've advanced them to this high trellis, so we can actually see how they work as a variety. And these are all single hill, and that's great. That allows us to get more chemical data. We can see yield data. We can see how it grows. But it doesn't give us really the full picture, right? So, but the single hill nursery is really the most fun for brewers, because they get to walk. We walk through here and get to rub each one of these varieties, and you get some really weird, wacky stuff. A couple years ago we had one. I called it the Hefeweizen variety because it was banana, cloves, a little bit of bubble gum. It smelled like a Hefeweizen in a hop. Unfortunately that variety didn't make the cut. So, but you do get a lot of weird, wacky aromas, and that's really what Nikolai and his team are trying to do, is find those traits. He called them, searching for freaks, that are those hops that have traits that are well outside the norm of what you see in varieties. on the market today, so we can bring the next generation of new and interesting hop varieties for brewers to use. So it's a lot of fun. I tell brewers, not to fall in love with anything here, because odds are good we're going to kill it. We look at each one of these varieties, and they have to give us a reason to not kill them, because like we said over at the seedling nursery, maybe 1 or 2 of those 3,000 to 4,000 will ever make it to a commercial variety. So we'll move over to the multi-hill nursery, and we'll kind of talk about what we're doing there right now.